If I'm given the graph of a parabola and want to write its equation, I can work backwards almost from the way we drew the graph from an equation for a parabola. So in this case here, I've got a parabola. It's got an x-intercept at -1, 0. It's got an x-intercept at 3, 0. And it's got a y-intercept at 0, -6. So my y-intercept is at 0, -6. I've got an x-intercept at -1, 0 and an x-intercept at 3, 0. So this here tells me that in my parabola, when x equals -1, y equals 0. So there must be an x plus 1 term. This piece here tells me when x is 3, y is 0. Well, the only way that can happen is if it's x minus 3 is my term. So I think y might be x plus 1 times x minus 3. But I've got to check in this third point, my y-intercept. If I take this parabola I've got here, x plus 1, x minus 3, and I put x equal to 0, I'll get my y-intercept. What did I get this time? 0 plus 1 times 0 minus 3, which is 1 times -3, which is -3. Oops. I wanted to get 6, or -6, sorry. I wanted to get -6 for my y value. So I can multiply this by 2. If I multiply every step through here by 2, 2 times that, 2 times that will give me my -6. So my parabola wasn't x plus 1 times x minus 3, it was 2 lots of x plus 1, x minus 3. So it's 2 lots of x plus 1, x minus 3. This parabola here is y equals 2 lots of x plus 1, x minus 3. So I used my knowledge of the x-intercepts, or the roots of the parabola. If there's a root at -1, 0, one of the terms must be x plus 1. If there's a root at 3, 0, one of the terms must be x minus 3. And then I knew that the y-intercept was when x was 0. Now I tried x plus 1, x minus 3 with x is 0, and I didn't get my -6, so I had to scale it, and this value here was a scalar. I scaled it to give my y-intercept.